All right. Hey, everyone. Welcome to a special edition, maybe.
Ooh, special. Me. Exciting.
Say hi to Ira.
Hello.
It's my partner, Rust programmer as well. And for today, we figured we'd go over the Rust 150 patch nodes together.
Yeah, I'm excited. This is going to be exciting. So I was going to say, I've never seen one of your updates before. I'm sorry. But you usually give me an update, I guess, in real life, and I don't want to spoil the fun you have with that. So can you walk me through what you usually do?
Yeah, sure thing. Just like for the record, like, do you read the patch notes?
Yeah, sometimes I do, yeah.
Okay, cool. All right. So the format that I do these videos in, also for you viewers at home, is so there's every 6 weeks there's a new Rust release. I've been doing it for like 50 times 6 weeks, so I believe 5 years or so. And there's these blog posts which explain the highlights of this patch. So here's for 150, and then at the end of the blog post there's like, here's the detailed patch notes, which are essentially all the changes covered, not just the highlights.
Nice.
So I first go over the highlights, and then we sort of dig a bit deeper. And as we go through them, I like to test features out that seem relevant. Sort of give some background on some of the things that I know, like the reasoning for. Some of the contributions in, for example, this release I've made. So I can like explain what's going on somewhat in detail. So yeah, you know, together we then cover all the patch notes and are up to speed with all the new Rust things of this. What's the word? So there's monthly, there's bi-weekly, there's what's for 6 weeks?
That word does not exist in the English language.
This hexa-weekly interval. Something like that?
Yeah, sure.
All right. Yeah. So would you like the?
Do you actually read?
I kind of do.
Sure. So the Rust team is happy to announce a new version of Rust, 1.50.0. Rust is a programming language that is empowering everyone to build reliable and efficient software. If you have a previous version of Rust installed via RustUp, getting Rust 1.50.0 is easy as RustUp update stable. Hey! If you don't have it already, you can get RustUp from the appropriate page on our website and check out the detailed release notes of this release on GitHub.
Yep.
Would you like to take it away?
Sure thing. All right. So detailed release notes is what we'll be looking at later. So we'll follow up on that after this. So all right. So what's new in Rust 1.50 stable? First up, Const-generic array indexing.
Oh, hey, more Const-generic stuff. Nice.
Yeah, like more Const-generic.
Wasn't there something else that landed recently?
Ooh.
Was that in Nightly?
Yeah, I'm not sure.
Was it this that landed in Nightly and we were talking about it? Or was it a different thing that landed in Stable and we were
I am not sure. So I know Rust 151, which is the upcoming release, is going to have tons of like Const-generic stuff.
Yeah.
I think this might be
the first one.
Yeah, not quite yet. That yet.
Okay.
All right. So, I can read this one and maybe share some stuff. So, continuing the march towards stable const-generics, this release adds implementations of ops index and index mute for arrays. Tn for any length of const n. The indexing operator already worked on arrays through built-in compiler magic, but this type level arrays didn't actually implement the library traits until now. All right, so it sounds like you can use index and index mute if you have like an array. So anything that is generic over index or index mute now will also accept arrays.
That's really sweet.
Yeah, so let's take a peek here. We have a function second, which takes a reference to some type C, where C implements index of usize, so you index with a usize, and it doesn't need to be sized, which has some properties that I always forget what they exactly are. But essentially it means this can be an array. I think that's a novel part of this. And then here we see let array. We initialize an array. And then we pass a subslice of that array. Okay, that worked before. And now it also works directly.
With an array.
Oh, cool.
Reference.
So I think it means you can just drop this.
And just pass an array. That
exactly.
sounds so much more economic.
Yeah. First you need to know about this little bit of magic. And now you don't.
Yeah.
Cool.
I have a side thought.
Yeah.
Have you noticed how so many examples in Rust are about containers, boxes, rectangles, squares? Is Rust a cat?
I knew there was a pun coming.
Oh, come on.
Moving on. I think Rust's a crab, though.
Really?
It's a
Not
crab.
a cat?
That's a crab.
Maybe crabs are sort of like cats and they also like boxes.
Like sea cats.
That's very different species from crabs.
Could be. Okay.
Yeah.
Maybe in their hearts.
Moving on.
Okay. Do you want to do this one?
Sure. So next thing that's coming on is const value repetition for arrays. So arrays in Rust can be written either as a list, so A, B, C, or repetition of x over n. For lengths n greater than 1, repetition has only been allowed for x's that are copy. And RFC number 2203 sought to allow any const expression there. However, while that feature was unstable for arbitrary expressions, its implementation since Rust 1.38 accidentally allowed stable use of const values in array repetition. So what does that actually look like?
I just realized the font might be a little bit small, so quickly upping the font size.
That sounds great.
There.
Oh, my eyes, I can see again.
Yeah, especially for people watching on mobile. This might be...
Yeah, might be better.
Yes. Sorry.
Right, so we've got a function main and something was not allowed because option of vec of i32 does not implement copy. So we had an array definition that returned an option of vec 32 with none over 10. I actually do not know how to read this properly. How do you read this usually?
So it's an array of like just none of length 10.
Of length 10. So would you read that like, I know what it is, but I don't know actually how you read it.
I mean...
Array of none with a length of 10.
I mean, you can also just drop the type because people are also looking at it.
I guess that's true.
So an array of length 10?
An array of length 10.
Or an empty array of length 10?
Yeah, but the important part is this is not allowed. And so what's happening now is we define a const of none, which is an option of vec i32, which is a none, surprise, and a const empty of that's also an option of vec i32 that defines a sum vec new. But repeating this const value is allowed. So if you have a let nones that defines an array of length 10 that is none, which is this none we refer to here, we can also do the same thing with empties. If we have an array of length 10 with an empty, that is also allowed.
Interesting.
Do you use something like this in your everyday?
There's a little bit more here.
Oh, yes. Let's read that out. So in Rust 1.50, that stabilization is formally acknowledged. In the future, to avoid such temporary name constants, you can look forward to inline const expressions per RFC 2920.
Cool. So it seems like something got accidentally stabilized, which...
Womp, womp, womp.
Human soundboard.
I provide entertainment.
You do. Yeah. So something got accidentally stabilized, and they're just saying like, well, it's intentional now.
Well, I guess it's good. At least like,
yeah,
everybody's kind of aware.
Yeah, exactly. So it doesn't really add anything new to language per se, but I guess it's like formally acknowledged, so it kind of does. It sounds like right now, in order to, so you can't directly say create an array of none. You need to assign it to a const item intermediately, and then you can initialize it.
Bit lengthy, but at least like I think it's very definitive as to what you want.
So RFC 2920, status on that is RFC PR Rust issue. We can see how far that one's off. Oh, this one's open, and do we have stabilization PR anywhere? Probably not yet. Oh, primary implementation PR. Oh, not yet stabilization. So it's still like not stable. It's not up for stabilization yet.
How do you tell that from an issue, actually? I don't usually look at these. That's too far down the line for me.
Yeah. So every issue has, or every like Rust feature, you can tell the feature, like here, has a name, inline const. Right. Within the code. It's labeled as such, and you need to nightly say enable feature inline const.
Yeah, that's something I have done before, not for this one, but
yeah. And like all of these, they have a related tracking issue.
Right.
So this is the tracking issue for inline const expressions and patterns, and these go through stabilization PR.
Right.
And if it's a libs feature, the libs team signs off on it. If it's a lang feature, a lang team signs off on it. Sometimes there's like sub teams who have like the ability to accept specific things. For example, the error group can probably carry some error stuff. And yeah, so here they're referencing an RFC which has been accepted, but not yet stabilized.
Right.
And doesn't have stabilization PR quite yet.
Cool.
So we just checked the status of that, and it seems to be coming along, but not here yet.
Cool. Thanks for the overview.
Yeah, of course. I'll take the next one.
Sure.
Safe assignments to manually drop T union fields. Oh boy. Rust 149 made it possible to add manually drop T fields to a union as part of allowing drop for unions at all. However, and this is going to like take some time to unpack. However, unions don't drop old values when a field is assigned, since they don't know which variant was formerly valid. So Safe Rust previously limited it to copy types only, which never drop. Oh, that makes sense. I never realized that. Copy types never drop.
I
Fascinating.
guess, yeah.
Of course, manually drop T also doesn't need to drop. So now Rust 150 allows safe assignments to these fields as well. Okay. All right. So do you know about the union type?
I do. I've never known there was a manually drop the functionality at all. That's very interesting. Should we implement this one?
Maybe that's a good one.
I feel like that's a good one to implement. Yeah.
I think it's like useful to like sort of go over what a union is in Rust though.
Definitely.
So in C, you typically have like not for you because you say you already know this, but like for people who might not. So in C you have a notion of tagged unions and untagged unions. A tagged union is essentially a Rust enum, where it says like here's like 3 values or whatever, like 3 different things, yes, no, maybe, for example, that can be a union. And it within the data, within the container itself, it knows which one of these it is. Right? Am I variant 1, variant 2, or variant 3? It has a little tag in front of it that mentions which one it is. An untagged union, however, does not know which one it is. Like the position, like the variant is being tracked somewhere else.
Right.
That makes it unsafe. So it's only allowed in unsafe Rust, and it's only really used to interface with C, which has untagged unions like pretty commonly in a lot of places for FFI bounds. So this is mostly relevant if you're writing FFI Rust, like Rust that interfaces with C libraries, Rust that like talks to C++, that kind of stuff.
It probably explains why I've never done manual drop.
Manually drop, however, is not for that.
Really? Okay.
Yes.
I just never came across it.
Yeah, I'm only covering Union here so far. So it's like a kind of like unsafe version of enum is the best way to think about it. And manually drop, what it does is it says this type, the drop destructor, will not run unless you call it manually, right? I think that might be like a fun one just to like type out. Stdmem manually drop. How do we get it? Is it just, oh yeah, it's in stdmem. Stdmem manually drop. And then what's the thing that implements drop? We can't print line from drops. Yeah, I'm not too sure. So struct foo, impl drop for foo, then drop and self, something like that. Counter usize. Let's do a counter, and if we drop it, decrements the counter, but you can't observe it then. The ideal way is to do something with a mutex. Mutate the state and mutex, and they were like...
That would be too long for this video, I think.
I think we can just do it in pseudocode, maybe.
Sure.
Runs here. Right. Now if we do let x equals foo counter 12 or something, right? Then x runs out of scope here.
Yeah.
And gets dropped, right? And like whatever destructor happens, like the file handle closes, the network socket closes, the counter gets decremented, whatever, right? But if you wrap this into manually drop, I think it is, right? Then now X's destructor will never run. Oh, typo. Oh, pubstrict foo. Hey, I typoed two things. Yeah, and now X is like never used, and this will never drop. Like manually drop is useful when, say, for example, you're messing around with std sync arc to do some sort of like reference counting, and you want to do something very specific with it.
Right.
In certain cases, you want to leak memory. Is that right? There's stdmem leak, etc. Yeah, it's very specific and niche use cases, but they recognize, like it's for people like doing FFI stuff sometimes as well. But people realize like, hey, the constraints of like whatever was going on now, or yeah, whatever was possible for like union stuff. I forget what this exactly is. Save assignments to manually drop to union fields. You can now use this together with union. The interaction there is actually sound, is what they've proven. So now it's allowed, and I bet like this will make FFI programmers happy.
That sounds good.
Yeah. I'm contemplating whether or not we should like cover why it is safe to leak memory in Rust, but
I perhaps think that's a different video recording.
Yeah, that's probably like going too deep.
That'll take us some time too.
Yeah, I guess we should like...
We'll leak some time.
Oh God. Yeah. Anyway, maybe the summary there is it's safe to leak leak memory in Rust. That's perfectly okay.
In certain cases.
In all cases.
In all cases.
Yeah. Memory leak's not a bug, or it might be a logic bug. It's not a soundness bug.
Should we go on to the next one?
Yes. You want to take it?
Sure. So, a niche for a file on Unix platforms. Some types in Rust have specific limitations on what is considered a valid value, which may not cover the entire range of possible memory values. We call any remaining invalid value a niche, and this space may be used for type layout optimizations. So for example, in Rust 1.28, we introduced non-zero integer type, like non-zero U8, where 0 is a niche, and this allowed option non-zero to use 0 to represent none with no extra memory, which is cool. So on Unix platforms, Rust's file is simply made of the system's integer file descriptor, and this happens to have a possible niche as well because it can never be -1, of course. System calls which return a file descriptor use -1 to indicate that an error occurred. Check error no. So it's never possible for -1 to be a real file descriptor. So starting in Rust 1.50, this niche is added to the types definition so it can be used in layout optimizations as well. It follows that option file will now have the same size as file itself. Cool. So I guess when we do option file, -1 is now a valid thing, and it'll have the same, will not use up extra memory.
Yeah, so the none value will be represented as -1.
Yeah, that's pretty cool.
Yeah. So for people who may not have heard of this before, like if you have an option of a Boolean, like the total amount of states that are represented within it are like none, some true, and some false. So it's like 3 total like states. If you encode that as binary, I believe you need 2 bits for that total, right? So if you have like an option of like a couple of Booleans or whatever, you can maybe like even like store a little bit of extra data next to it. You can end up packing like a lot of information into like a single U8, into a single byte. And that's what all this niche stuff is for. It seems they applied it to file as well.
It seems it makes it easier to work with file descriptors.
Yeah. So one thing that sort of like sidetracking, but like expanding on this slightly.
Oh no.
We're here for sidetracks. It's the point of this recording.
Sure,
where I'm like, I can give you some background. So there's like still conversations, not very actively, but people are like still wondering about like ways in which we could expose these kinds of layout optimizations to end users, right? Because say I, a user of Rust, right, a Rust programmer, would like to define my own Boolean type and my own option type. I don't get any control over how memory is laid out.
Right.
Right. Not properly. I can't be like, well, I want this bit to be there and that bit to be there, and like this is the niche. This is all like somewhat magic-y within the compiler. So one cool thing would be if like eventually like Rust gained the system to declare a memory layout where you could be like, here is a struct. This struct contains like 8 Booleans, but the actual memory layout is like this, or something like that. You know, but we're not there yet. But it's being used internally, quite all over the place. Yeah.
That was an interesting sidetrack.
Hey.
It's
the point of this recording. It's the point of the show.
Point of this
What point? All right. Cool. Library changes. Ooh, that's a fun one. So there's new stable functions. So I guess like what this covers is mostly lang features, and now we're like on to what the libs team's up to. So we have Bool then. This one's really fun. Okay, we can type this one out.
I'm still reading the docs.
So
you're too excited.
I'm super giddy about this one. Super giddy.
Okay.
All right, maybe you can. I'll be clicking a lot.
On y va.
J'allais? Okay, so let's say let x equals option of u size, right? And then we say it is sum 12, right? Say we wanted to like do a little switcheroo on this, where we wanted to be like, actually we want to true, but Oh no, I'm flipping it around. Oh no.
I did not follow your thoughts.
Okay. Sorry. I'm just too giddy. I start typing before I start thinking, and that like rarely ends up going well.
No, it does not.
So you may have seen this one. If true, sum 12. Else none. Right, and then X is in this case option usize. But you can probably scratch that and just be like 12U8. 12U8.
Okay.
Have you seen code like this before?
I don't think so.
All right. I've written this like so many times. Where it's like if conditional, right? If X or if 12 smaller than 24.
Oh, I mean, yes, with that kind of thing, sure.
Yeah,
and then
yeah,
you do just like I have written a conditional before.
Yeah, but like specifically a conditional, which like outputs like either some variant or a none variant.
Yes, I have written that kind of conditional before.
Yeah, it's pretty common. So some people then prefer to write it like this, right? So match 12, and then here they do like some kind of like binding.
Yeah.
Like X where I forget the exact thing. Anyway, we no longer need to do that, and we can just simply do. I guess it's like const equals 12, 24, 4 const dot then 12U8.
I see.
Right.
That's really sweet, actually.
So now we have them side by side. Please work. Please compile. Bool to option. Oh no. What version of the compiler are we on? We are on stable 1.49.
You need to update.
Okay, we're going to beta. It's still not updated. It's fine. Yeah, there we go. Right. So it works.
Right,
150.
Yeah, just not used. Cool. Yeah, this seems like a lot cleaner code.
Yep, I agree. It's just a nice little one-liner. There was a big debate over the naming, but it seems people were kind of like, naming's whatever. We're just going to go, like, then is good enough.
I think that then makes sense.
Yeah, I agree.
If condition is meant, then do that. That seems like a English representation. The next one, B-tree, map, entry, or insert with key. Oh, no, I did something wrong, sorry.
No, it's fine.
Which one is
Sure.
your keyboard? Does not make sense to me. Do not like your keyboard. Right, I think this is just like an extra method for the B-tree map that will probably insert a key. Ensures the values in the entry by inserting, if empty, the result of the default function. This method allows for generating key-derived values or for insertion by providing the default function a reference to the key that was moved during the .entry key method call. The reference to the moved key is provided so that cloning or copying the key is unnecessary. That's really nice. Unlike with or insert with. That's really cool, actually.
Nice.
Yeah.
I think the pattern this replaces is the one where you check, does my hash map or B-tree map, both of them seem to have gained disability.
Did they?
Yeah, I saw it a little bit down in the list.
Oh, nice. Yeah, okay.
Yeah. I think what this replaces is like hash, like map dot contains X, then insert value.
Yeah, it's like
then
always
get value.
I have so many pieces of code like that.
Oh, and then it's always like dot get value dot unwrap.
Oh yeah,
right.
Yeah, absolutely.
And that unwrap is like not perfectly efficient because it contains now panic message, and doing it perfectly efficient would require unsafe.
Like, this is a good line. I like this line a lot.
You like it? Yeah.
Oh, I didn't see the pony land.
Okay.
I was literally talking about the code.
So I was sort of assuming you were making jokes again. Like, I love pony land. But yeah, no, for sure. Yeah, map.entry key, and then the key just flows through into here if it didn't, and then you insert the value. Yeah, it is amazing.
Cool. Sounds good.
So I'm really hoping they'll like put out a Clippy lint for this one will come out, because you'll see like replacements of like 6 lines of code to be like, oh yeah, just use
do this.
or insert with key.
Sounds like a PR somebody should make.
Yeah, it's true. That'd be good. F32, F64 clamp. So both of these are the same.
Clamps are good.
Clamps are good. I've only like ever seen it for like what's that, GPU programming, UnsafeCell, like clamp functions to like interpolate between like things.
Yeah, no, I think they're very common with decimals, and this is for F32 and F64.
Yeah.
When I did the decimal 128, clamping was also part of that. It's actually a pretty difficult thing to implement, but I was surprised F32 and F64 doesn't have it.
Oh, let's actually look at the implementation. Is this clamp? No, that's total compare.
Oh, clamp. Oh yeah, that's nice in Rust. The implementation I was looking at was Ruby, and that was a little bit more complicated. Nice. Yeah, of course, if it's between the two values.
Oh, what? It's running with an assertion. Fascinating.
Yeah, I think because this particular function is meant to make sure that the minimum is not larger than maximum, or is that usually done differently instead?
So virtually like every number method instead only ever runs debug assertion.
Oh, okay.
And if the invariant is exceeded, it will default back to 0.
Oh, okay.
It will never, ever, ever panic.
Maybe this is because it's a float?
Or because it's a bug.
Can you look at the docs again? I think there was something about the...
Yeah, so it says it panics if min smaller than max, min is nan, or max is nan.
Okay.
Like, it makes sense, but I've also like been in the process of like contributing methods to floats. The log, or not floats, but binary log.
Right.
And like one of the things that was pointed out was like that. I'm going to assume it's not a bug, but I'm still surprised to like see that, I guess.
Okay.
Yeah. Fascinating. Anyway,
cool.
Have we like covered what clamp does even?
I don't think we have, but clamp usually makes sure that the value of the decimal is not greater than the provided maximum, or is...
Yeah.
No, I fucked up the left and the right and the greater and the maximum. It has to fall between the limits that are provided. There we go. I don't have to explain left and right.
True. I wonder if it could like be optimized even further. If x smaller than min, x equals min. By definition, it will then like never be bigger than max, because we've already asserted that. I think this can be an else if. Maybe.
maybe somebody will beat you to a PR to fix that.
I'm not invested. I was just like, huh? So it's F32 clamp, F64 clamp,
and an ORD clamp.
ORD clamp. So anything that's ordered will also have a clamp. I think it's because we don't like have a generic like float type.
Yeah.
But probably. We like ORD is implemented on numbers. Am I getting that right? Yeah, on integers, non-floats.
I think, you have to implement a specific ORD for floats.
It's
yourself.
Partial ORD.
It's partial ORD, but if you want an ORD,
Exactly. Fascinating. All right, cool. You want to take next one?
RefCell take. I have to do the keyboard thing. No,
Yeah.
You press the button. I don't know. Keyboard. Keyboard.
If you're looking for the control button, it's the one with control on it.
You know what? I have a special keyboard. I have a keyboard here.
You got your own keyboard.
I got my own keyboard because I hate your keyboard.
Okay. Hey, don't hurt my keyboard's feelings, please.
I'm sorry, keyboard.
Yeah, all right.
So a RefCell takes the wrapped value, leaving default in its place. Panics if the value is currently borrowed. But we expect that. Right. So examples: RefCell new 5. You can take that away. Okay. I don't use RefCells too often. How does this method sound to you if you used RefCell before?
So a RefCell, you say you use it too often. It's the non-send counterpart to arc.
Definitely have not gotten into that.
Yeah. Have you used arc? You've probably used arc before.
I've used arc before, yeah.
Yeah. So arc uses atomics to synchronize between threads. And that's kind of expensive, right? So if you know that the value will never be sent between threads, some things just never are or are not thread safe to do so.
Right.
Right. Then RefCell is a great structure. It's way faster because it never synchronizes. So, no atomics. In this case, like a RefCell, what allows you to do, it allows you to have multiple references to the same value, like shared references to a same value. You can't mutate them. RefCell does give you mutation. Sorry, I'm thinking RC. Yeah, it gives you, this is not like arc. This is like mutex.
Okay,
Sorry.
well, that's a horse of a different color.
It is. Sorry, my bad. Yes. This is the non-send counterpart to mutex.
Okay.
So you get multiple mutable handles to a single value. Usually it's not allowed in Rust.
Right.
Because either a value is shared or a value is mutable. Never at the same time, because that's how you get data races.
Right.
But this enables you to do that because it locks and unlocks.
Right.
And the trade-off for that is you now have a chance for deadlocks.
Right. So then when this method comes in, when you take the ownership of that particular value, but what you do is for other processes that want to access this, you leave the default in its place. What the other processes then read is the default value. Is that correct?
What the other processes read is the default value.
Or does it... Or does the 5, so let 5 C take, does the 5 then have the lock on C entirely?
Does the lock have on C entirely? So in this case, it removes the value. So
it removes the value, so it doesn't take ownership of the value. Well, I guess it removes the value, it takes ownership of the value.
Yeah. I think maybe if we turned around slightly, this is, I think, useful when you have temporarily shared mutable state.
Okay.
Right. So say we have an array we want to write a bunch of values into, because we have like some sort of like parallel thing on a single thread. It's kind of uncommon, but whatever. For the sake of argument, let's pretend that that's the case. Maybe in JavaScript, right? So we create like a mutex, like a tiny mutex, like a non-send mutex around this thing. Everyone gets to write their output into a thing. And then once we know that all the worker tasks have completed, we take this thing again and we take the vec out of it and we continue with the results.
Okay.
So it's like a fan out, fan back in pattern you could use this for on a single thread. I suspect that this is I want to just quickly see if arc has a take method. Does arc have... No, sorry.
Mutex.
Yes. If mutex has a take, mutex has no take. Fascinating. Okay, I think we could add mutex take. Maybe. I'll have to look better at it, but I would assume that, if RefCell has a take, then mutex... I imagine mutex had a take, and that's why they added it here.
Oh, I guess they needed it for RefCell, but I suppose mutex might come later on.
Maybe, or maybe nobody thought of it. I'd sort of place my money there.
Okay.
Yeah, I recently refactored like a whole bunch of these things, and yeah, like so that just sounds like a PR in the making, unless there are like concrete reasons why can't it be. I haven't looked at it, but yeah, I don't see why not. So probably that's something that could be done.
Cool.
Yeah.
Somebody should take the PR.
Yes.
Oh yeah. Slice fill.
Timed it perfectly. This one's mine.
Yes. Oh, like legit yours?
Yeah, I made this. Like, yeah. So I was.
Would you like to take us through slice fill?
Yeah, sure. All right, so slice fill. This one's fun. Ooh. Oh, wait. Did they include my? No, real quick. Sorry. I need to verify something. Did they? No, they didn't. Haha! I get to show something that's not even in the patch notes, I think.
Wow.
I know.
Wow.
I know. It's kind of cool.
Prime information.
All right.
Sneak peek.
Very
Unseen before.
Kind of. So, if you're writing C, which for me is almost a decade ago at this point, the way you like interact with like the heap is usually through the alloc API, and then there's some stuff like memset, like some other things. I forget the exact names. I haven't done this in a while. I need to look it up. Free is the one I couldn't think of.
Free.
Yeah, so okay. Alloc, free. There's memset, which is like an efficient way to be like, please have this slice of memory, and we're gonna write some data into this slice of memory, like very concretely. Highly unsafe, because say you say, okay, we have a vec of size 10, but we accidentally threw an off by one error. We write 11 bytes into it. We now have caused a buffer overflow.
Right.
And that's a security vulnerability.
I'm having a deja vu. I think we have had this conversation before. But our viewers have not heard this, obviously.
Anyway, but memset is how operating systems, they expose it through the C API. And they're like, well, here's like a really efficient way to set memory, right? Rust is like, well, it's highly unsafe, so we don't expose this. Instead, we have all these other APIs to set memory. However, one thing that was like very much missing from all of this was a direct comparison to like what memset does, which is like, here's an array, here's like a sequence of memory, please assign the value into this. So what people would then do is like say, is let x equals, needs to be mutable, vec, does this work? 10 usize or whatever is 4x in, let's name this, what do people call this? Values. For value and values equals something like that. Does this compile? I think it compiles. Right. Say we want to unset this like the contained values, right? Usize not a value, cannot be dereferenced. Okay. Do you remember how to write this?
Isn't it usize 10? Usize semicolon 10?
Oh yeah, I think you're right. So that is, that's
shit.
Even worse. It's 10 usize because we give the value and the type, and then how many times we do this. Type usize cannot be dereferenced. Anyway, as you can see, this is a little bit tricky. Is this nmut value, something like that? Oh god. All right, this is becoming somewhat absurd. Anyway, as you can see, if you want to like go over every single value in values and turn it into a 0, you need to reference it in there and like be like, okay, cool. Maybe it's as simple as this. I hope it's as simple as this.
I've removed them. What?
Yeah, at this point I'm like clueless. Anyway, no more messing around.
So what do you do now?
Values that fill.
And then just give it a 0?
Yeah, I believe that's it. Let me see. So 1.51 is stable. No, beta. Run.
You're
Yeah,
gonna
right.
fail.
Yes. Okay, let's validate. Expected use size, found closure. Ah, yeah, there we go. Yeah. So fill just takes a value.
Okay, I have a sidetrack.
Yeah, go.
Side quest.
Side quest.
Can we fill it out with bits instead of an actual like use size? So if I want to fill it out with like, let's say this is not 10 use size, this is 10 U8.
Yeah.
Instead, and I want to fill it out with like legit bits. Can I do that instead?
No. So
You're useless to me. I'm kidding.
So what you're looking for, like the signature for more or less what you're describing, would be if Rust had a U1 type, right? Like single bit integer, then we could do something like that.
Right.
But we don't. So the smallest like amount of memory that we can talk about like concretely is a U8. So it's 8 bits at a time. LLVM has something for U1s. It exists. You can have arbitrary sized integers. C does the same thing. Rust doesn't. Everything's like aligned to 8 bits. However, call back to what we talked about earlier. It's the exact, if you were able to declare the exact layout of your structure,
Yeah.
right? They could, for example, be like, oh, here's like my 10 Booleans or whatever. But those would actually then compile down to bits, individual bits, guaranteed in that order as well. So that could be one way to go about it. But yeah, short answer, no.
Cool. Well, I'm glad we completed the side quest.
Yeah.
No, hold on. We didn't complete it. It's a failed quest.
Right. So to finish like the little riff here, what's really cool about this is we just said values that fill 0. We can like use any value here, values that fill 1, 100, options. We can do it with like even like pointers or whatever. It just works. It just sets the whole thing. You can also do a subslice.
Oh, cool.
Right. So this works on slices as well. It's kind of fun. I think this should
neat.
work. Please work.
Yeah.
Yeah, there we go. Yeah, so it works on slices as well, which means you can also subslice it. So you can be like values 0 ... 2 .fill, I believe, and then we'll see like 2 zeros and the rest are 10s. Maybe it's easier if we turn it into 1s, but compile speeds, hey, right? So just the first 2 are set. It's nice and flexible like that. And the really cool thing about this is if you look at the output assembly, this generates just a simple syscall to memset.
That's nice.
Removes like all the overhead, and it's just about as efficient as it can be.
And also the API seems ergonomic, which is it's nice to work with.
Exactly. And now for the thing I was so giddy about.
Tell us, Yash.
You can just look for memset in the docs, and you'll see memset aliased to slice fill.
It's really cute how you're excited about it.
No, but it's so good.
It's good. It's good.
All
But
right,
it's
all
also
right,
cute
right.
you're excited about it.
All right, I'll do you one better. If we look for alloc, oh come on, please work. Alias, where's my alias? No, was it merged too late, malloc? All right, and Rust 1.51. yeah, it's coming out. But yeah. So you can just look for memset and you'll see slice fill, which is like just trying to lower the barrier for people coming from C and C++ to Rust and trying to find the things that they're already familiar with, or just like, oh, here you go.
Nice.
It's right here in the docs. We understand you.
Nice. That's actually quite welcoming.
Does this work? Oh, no, wait. Promise. Yes. That one too. I did that.
This one's for the JavaScript developers, I take it.
Yes, exactly. Anyway.
Cool.
Yes.
UnsafeCell get mute.
UnsafeCell get mute. I'll let you take that one. Oh, we should zoom in?
I'm just happy I have my own keyboard. Yes, zoom in, please.
All right, yeah, sure.
So get mute on UnsafeCell returns a mutable reference to the underlying data. This call borrows the UnsafeCell mutably at compile time, which guarantees that we possess the only reference. I think this makes sense. That's a pretty standard API for all the stud items. Yep. I guess we were missing this from UnsafeCell.
Yep. I believe this one exists in Arc and RC as well.
How about we check?
Get mute. So Arc, get mute, RC, get. Ooh, no RC get mute. Fascinating. PR in the making.
This talk show is basically telling you all the tips of the PRs you should be making.
Here's a library contributor going over library contributions. No, it's literally like how I find like what to contribute for a good part. But yeah, it exists in Arc, doesn't yet in RC, but now it also does in RefCell apparently.
Yeah.
Or UnsafeCell, sorry.
And then we have a couple of functions that were made into const.
Yep. This all is like very easy. It seems that we're almost like the important part here is like we're almost all of the integer functions are const.
That seems really good.
Yeah.
I mean, yeah, it's just a power of 2, power.
And like it's just steady progress, but we're pretty close to just you can do all the math you'd like at compile time.
That's good.
Yep.
And the 2's IP address is IPv4 is IPv6. That seems like it's just checking for an enum for a bool kind of thing.
Exactly.
It also makes sense to be a const.
Yeah.
Yeah. That just returns a bool. It's not even.
Exactly. So I have a fun one on const.
Yeah?
Yeah. Like what? I'm somewhat excited about it.
I know, it's cute. Go on.
All right. Like people might notice that like every single like REST PR or release comes with like tons of like new const functions. It's like, oh, here's more const, right? So I recently had like a chat with Ollie about this, who is one of the people working on const. Yeah. And like what a fun question to ask yourself is like, what is the end game? Like where do we end up with const? Like, what's the final stage? Like if everything's becoming const, like where does that end up?
And what do the wise people of REST say about it?
So there's a fun like possibility here, where if pretty much every single function is const, then at some point it begs the question like, should functions be const by default? And should const be opt out rather than opt in?
Oh, that's an interesting way to think about it.
Yeah. Like there's no concrete proposal like for any of this, of course, but there are like some clear limitations of things that cannot be const by its very nature. Statics cannot be const. They're like initialized at like runtime. I hope I'm saying that right. But then, for example, file system access network access. File system access, there's some asterisks there. But network access, very clearly, we do not want to allow that at compile time. So, that will never be const. Anything calling into that will never be const, right? But yeah, I think that's I thought that was a fascinating thought. That we may indeed one day see like you need to opt out of const rather than opt into const. And all these like const markings will just go away because it's just always supported.
I think that would be really nice for especially like mathy functions or some of the stuff that we don't need to think about at runtime.
So you follow Ryan Levick on Twitter?
I don't think I follow them.
Okay.
But I know them.
Yeah. So he's been making like some really fun packages recently. Where he's like, what was it? Some sort of hashing function that like ran like a SHA-2 hash that ran at compile time.
Oh my god.
Yeah, no, it's really nice.
That's fun.
It was like certain things, like they're essentially wrapping all at Microsoft. Ryan works at Microsoft, and
that's a good
yeah
thing to start off with.
And they're essentially wrapping all of the Windows API and exposing it to Rust. And they're doing a lot of stuff, and there's like lots of like 30, 40, 50 years of work into the Windows ecosystem, right? That they need to support as well. But yeah, they were like, oh cool, like this one feature here like dropped our compile time by 20 minutes, and like here's this other thing. So it's kind of fast.
20 minutes?
Something like that.
That's amazing. Holy shit.
Yeah. I don't know the exact details, but like we had lunch one time and he told me about it. And like, yeah, it's really cool to see like how these tiny little const functions that you're like, oh, that looks like a fun exercise. And it's like, no, this is super practical for like some of the build things that we're currently doing.
So once again, this program is encouraging you to make contributions to the Rust language. Should you see when something needs to be const?
Yeah. All right. So I think we're like coming up on an hour. Let's dive into the extended patch notes.
Sure. Yeah, that sounds good.
Are you good?
Yeah, let's do it.
All right, cool. So this is the less nicely formatted and explained version. It's just a list of stuff.
Zoom would be great. Can I? Oh man.
I'm trying to take over my keyboard.
Yes, but it's not possible.
So we already covered this: language features, const values, etc., etc. These are new.
Oh, cool. Unknown FreeBSD on x86-64. Tier 3 support for Arch64. Apple iOS, and a Tier 3 support for ARM v5te on the Linux. I do not know what that target is. I think I've...
Ooh, nice.
Which target is... nice.
Okay. So, wait, ARM... no, it's ARM. I thought it was RISC-V, RISC-V.
No, it's ARM.
Oh, cool.
Cool. It's nice to see other platforms getting some support.
Yeah. So you know about support tiers?
I know some of ours we do tier 1 and tier 2 for the builds that we build. Specifically, like the M1 is a tier 2 support. I know that, and we need to start building our target for that. I actually don't know what tier 3 signifies because I do not think I've built anything for tier 3 yet.
That's
do you know?
Not super surprising. So tier 1 is essentially Windows, Linux, macOS.
The big 3.
Yeah, I think it may even like include Android. Not super. No, it doesn't. It doesn't. Well, it's the platforms that every single commit, every single PR submitted, every single time runs against this, right? It's just part of regular CI. Tier 2 is before merge, I believe. Stuff gets rolled up and like sent through there, and like you test it out. And like tier 3, I believe it means if things don't fail. Yeah, here we go. Tier 2, guaranteed to build. And tier 3 is essentially all bets are off, I believe. We don't build or test
Automatically in ManuallyDrop.
Official builds are not available. Oh yeah, that's it. Yeah. Tier 3 is essentially all bets are off. We support this maybe. And I believe there's stuff like the PSP in here.
Okay.
Yeah.
Yeah, but I want to see M1 is still tier 2, right? Well,
yes.
I kind of imagine it's very recent. I don't expect it to be tier 1 just yet.
Exactly. So what I think the compiler is looking for before upgrading it is GitHub Actions CI or some other form of CI that's like directly integrated. I expect Microsoft/GitHub to likely bring this out because everyone wants this.
Well, yeah, we kind of got to start testing on this and make sure
exactly.
we don't fail. I definitely had like our target fail on Big Sur update recently, so that's fun. But yeah, interesting, cool.
Yep. So
what's next on the extended release notes?
Extended, yeah.
Extended edition.
Release notes after dark.
No, release notes, the extended cut.
Oh no. Oh, the Snyder joke, please.
What? Who?
Snyder. The Snyder cut. Oh, never mind.
Okay.
Moving on.
like Snyder as in the tailor?
No, Zack Snyder.
Oh no.
Director of Watchmen. Supposedly going to say. There's this movie called Justice League. It's not very good.
Okay.
So they pulled in a different director. I think it's a different director who gets to like montage the images back together.
Yeah.
In the version according to them.
Okay.
And people are hyping up the Snyder cut of the Justice League movie.
Okay, you know why that's funny? Because Snyder is also, Taylor and But also, like, usually, like, extended cut is, like, for any film that has extra...
It's true, it's true.
So, I was not... I obviously have not watched Justice League to begin with. And would not get your Snyder cut reference. Anyway, moving on. Nobody needed this.
Nobody asked for this. Nobody wanted this. It's still happening. We're trying to go out of it. It's not really working. So how's everybody's day? How are you doing? Like,
I'm so sorry you're up for this, right? So libraries introduced
Okay. A partial equal char character for proc macro punct. So this is if you're doing proc macro stuff. One of the types in procedural macros now implements partial equals.
That's cool.
Yeah.
That's always useful.
So yeah, very small, just a tiny impl here.
Aww.
Yeah.
Nice.
Easy.
Small is nice.
Cool. Ops index mute we already covered. Niche we already covered. Stabilized APIs we have covered. Stabilized const APIs we have also covered. Well, not in depth, but just there's more of them. Cargo. Do I take this?
Sure. Cargo added the build rest-c workspace wrapper option. This option sets a wrapper to execute instead of rest-c for workspace members only. Ooh. I want to read more about that. I don't know. Your mouse is wonky.
I can be a mouse duty if you want.
Oh no, it's okay. I can scroll my own windows. So.
Ooh. Are you reading that text?
Yeah, so stabilizing this environment variable would allow Clippy to fix a long-standing usability problem. Clippy 4612. It's also the last step towards stabilizing the --fix command argument in Clippy, which is very useful, I think. That allows applying suggestions automatically when the lint supports it. I want to look at the files changed. Right.
What are you looking for?
I just wanted to see more about what it does in general. But yeah, I guess this is what we kind of needed to know. Wrapper.
So I don't think this is particularly relevant for most people. But what it enables is super fascinating. Do you know about Clippy Fix?
I haven't used it, I think, a couple of times, yeah. But I didn't know that works for a workspace as well.
So Clippy Fix currently needs like a very long-ish, sort of annoying incantation. And then, but if you use it, it works pretty well, and like it just applies all suggestions that Clippy has, or well, good part of them.
Yeah.
Which is nice, and this works towards that. So what I thought for a sec this might be would be also to allow cargo wrappers. So you could, for example, imagine a version of what do you call it? The WebAssembly toolchain
Yeah.
to wrap cargo, but that's not what this is.
Yeah, no, that's not what it is.
Yeah, so
Okay.
seems nice. Cargo rerun if changed will now, if provided, a directory scan the entire contents of that directory for changes.
That sounds super useful.
Wow. So take it if you like have some sort of assets directory, this could be useful. Build script emits cargo rerun if change pointing to a directory, then cargo will scan the entire directory for changes. Oh, I should have turned off my chats. I've tried to make it semi-intelligent interface symbolic links. It checks the entire M time. There are a few other edge cases. It will skip it. Okay. This seems like an internal change mostly. I'm not sure how to configure it. Maybe there's a way. Maybe let's look at the files. That was actually a good idea.
Ooh, probably the
Seems
yes.
it's internal.
Yeah, that just. Oh, interesting. I thought.
Oh, this is for build scripts. So build scripts can output this.
Yeah, I was thinking maybe this is for. Yeah.
Oh, fascinating.
Do you use build scripts?
Rarely.
We got a couple. And it's kind of nice to package up the thing.
I guess I only like use them sort of transitively, or for example, like gzip or whatever is a C dependency that's compiled with Rust. Fascinating. So this is just conditional compilation for stuff like C dependencies that are run through build scripts.
That's super, I guess, neat if you have a bunch of these and it just cuts your compile time.
Probably.
Added the -- workspace flag to the cargo update command. Thank you.
Oh, what?
This is nice. This is nice. My -- bin project has a CI which updates the version number in cargo toml, which is then commits. However, this means that any further cargo command build test etc. will update the existing cargo log file, updating the root version, causing some frustrations for users. Furthermore, it breaks the publish command, which requires the repo to be current. I've added a sync log file command to simplify update the root version in the cargo log file to match the cargo toml in the same way that the simple commands like fetch do. If no cargo log file is present, the new one is generated based on the index.
Okay. Cool.
Neat.
Seems straightforward. Miscellaneous, the search results tab and the help button are focusable with keyboard and RustDoc.
That's a good accessibility addition.
Running tests will now print the total time taken to execute. Amazing.
Cool.
So we'll be able to time our tests. And we see it in action here. 1.3 seconds. Gesundheit.
Okay.
Amazing. Do you mind if I just like run over these real quick?
Sure.
Yeah. The compare swap methods on atomics have been deprecated. It's recommended to use the compare exchange and compare exchange weak methods instead. This will now emit a warning if you use compare and swap.
Cool.
Example, I think this may be one of the more relevant ones. There's no example, it's fine. Changes in how token streams are checked have fixed some cases where you could write unhygienic macros.
What are unhygienic macro rules?
All right. So macro hygiene. So what macros do is they do code generation, right?
Sure.
And like macro hygiene refers to how the outputted code interacts with the already existing code.
Right.
If you define an intermediate variable, right, will it accidentally shadow like a different thing? Will it accidentally overwrite something in its outer scope? Yes or no? Right?
Okay.
So there are ways where a macro could be generating code, which is invalid in the context of the program. and it's just a source of frustration when macros are unhygienic.
Okay.
So, like, yeah, because the output code, which essentially break the program, even though the macro by itself is valid. And
right, they modified the
code
data. Okay.
Yeah, exactly.
Okay.
So then fixing like a hygiene issue in macros essentially says we fixed a bug that could lead to broken code.
Cool.
Which is nice. Test as an inner attribute is now considered unstable like other inner macro attributes and reports an error by default through the left unstable lint. I don't know what they did here. There's probably a test somewhere in here for this field testing. Oh, so you can no longer do test within the output of a macro. It seems it is.
Oh, did not know that was a thing.
It seems that was unintentional, maybe.
Yeah.
Overriding a forbid lint at the same level that was set is now a hard error. So cap lints was ignored, previous forbid. It sounds like it's just the consistency. If you like defining a thing twice, it now breaks or something like that. Drop support for all cloud API targets. Do you know Cloud API?
No.
It's what WASI people tried to make WASI before WASI existed.
Oh, this was Cloud API?
Yeah.
It was, okay.
And then everyone switched to WASI.
I see. Well, I guess there's no reason.
And even people working on Cloud API dropped work on Cloud API.
Okay. I did not know this existed. I just know WASI.
Yep. Yeah, for a while it was kind of like people are going with Cloud API. What is that? And then nobody ended up going with that. So you can no longer intercept panic calls by supplying your own macro. Use panic handler instead.
Okay.
So if you set like a panic macro at the global level or something like that,
right,
to intercept it, bad idea.
Panic handler seems like a good thing.
Yeah, panic handler just exists. There's panic handler and there's out of memory handler. And there's a lot to be said there, which we're not going to do right now.
Perhaps not.
Semicolons after item statements now produce a warning. So struct foo semicolon, but only within macros. I think this was already like not allowed. So if we go to stable, struct foo, this should already like not be allowed.
Doesn't Clippy do that for you? Oh yeah.
But it might have been accidentally allowed within macros.
Okay.
But they removed it again.
Okay.
So that's good. I think that's it. They're talking about like lazy token stream and parse tokens. Those all sound like macro things.
Cool. And I think that's the last thing on the compatibility notes.
That's it.
What?
All right. Rust 1.50, it's a wrap.
Yeah.
All
Thanks
right.
for joining us.
Thanks for tuning in, everyone.
Bye.
All right. See ya.